you're constantly collecting in real time.
Yeah.
So having networks that can like adapt and be efficient for that as well, I think that is very important. And I think as the data size keeps growing, we'll be finding new problems.
Yeah.
I think that's part of the journey.
Sleeve.
Sure.
So happy to have you here. Thanks so much for both being on the podcast. And also, like, you're going to be speaking at the conference like this week, also. So thanks. I'm really
Of
looking
course.
forward,
Yeah,
to,
Nick. Thank you for the invite. I'm excited to be here and, tell people, give back to the AI community and yeah, just be a member of this community. So thank you.
awesome. Great. Great. Well, welcome. So, I'll tell you, so you're kind of at that intersection between AI and cancer research,
Yep.
now, and that's an extremely exciting space to be in. So I want to dive into that, but before that, I want to make sure everybody knows who you are.
Hmm.
So let's spend a little bit of time just talking about like your career path so
Hmm.
far. What brought you into kind of data science
Hmm.
and really focused around AI.
Yeah, of
Okay.
course. So I kind of have a very different background. I have a degree in mechanical engineering. So I kind of did that for a little bit. And then while I was actually in school during my senior year, I was interested in bioinformatics. So I took an elective to kind of learn more about bioinformatics, what it's about. And then that's when I learned about data science. And then I was initially drawn into that field. So I decided to go back to school and get a master's degree in data science from Northeastern University in Boston. So before graduating, I did some work in the lab, in the precision medicine lab, which initially got me introduced to cancer research and personalized medication. My master's thesis focused on different ways to use machine learning to predict genes, cancer susceptibility. So, yeah, that's kind of my path. And then after graduating, I got a job at Dana Farber, where I work on the data engineering team, just helping them build pipelines to kind of like, in order to make these predictions with AI and machine learning, you need the right data.
Yeah.
So that's why my job involves just building that system and infrastructure. So,
Yeah, it's awesome. Like the whole data governance and kind of data kind of stewardship
yeah.
is extremely important, especially in the AI space, but even more so important in kind of healthcare and cancer research in
Yes.
particular. So really important space that you're working on, and kind of thank you for doing that, as well. Okay, great.
Yeah.
So during our last meeting in New York, AI Networking Summit, we had a speaker. His name was Svigal. Svi is with Memorial Sloan Kettering Center.
Hmm.
So Svi presented their AI infrastructure. He didn't go into the data, which is where we're going to spend
Hmm.
a good amount of time here. But he went into the infrastructure that they put in place and then the advances that they've been able to make in cancer research.
Hmm.
He got a standing ovation on that talk, and for a couple of reasons. One, he basically let everyone know kind of rectal cancer is basically we have cures for that,
Hmm.
now,
Yeah.
and that we're working on vaccines for a wide range of different cancers. And he
Hmm.
was, kind of elucidating that like within 5 years, we should start to see like vaccines for some significant cancers that have
Hmm.
been um, troubling society for a really long time.
Yeah.
So this is your space. You're right in there. So
Yeah.
have you does all that ring true to you? Does that all that make sense to you?
Yes, it makes sense, but I believe the data is also very complex. So I believe with the change of AI, so I definitely see us getting closer to finding some cures or some vaccines for some cancer types. So yes, I definitely believe that's true.
Okay. All right. Great. Let's kind of dive into cancer research. So, basically, from the point of view of like how machine learning and AI kind of contributes towards the understanding and the research
Hmm.
of cancer. For the kind of the researchers
Hmm.
in cancer.
Yeah, for the research in terms of machine learning. So, for example, you have to study protein structures. Proteins they have a specific structure. It's very complex. So, just collecting that data in itself, it's very heavy, very hard to predict. So, my whole team, basically, what we do, we make the data easy to ingest for machine learning. So, we transform the data in a format which can easily be used for machine learning through various processes data pre-processing, data transformation, and then after transforming the data, we have it in an easy format. We give it to the scientists, and they can use that to make some predictions. So, for example, some of the predictions can be we have like normal like neural networks, or it can be a lot more in depth where we're using like long short term memory models. So there's different kinds of models which can be used, but we're very focused on machine learning and neural networks.
Yeah, awesome. Is there any particular? I'm sorry, like two questions competing in my head right now.
Yeah.
One is the availability of that data. So I
Hmm.
know that Dana Farber has a network of companies that and institutions that it works with.
Correct.
So a lot of the data that you kind of curate
Hmm.
and provide, that's then available to everyone in the network. So that data is shared for a wide range of researchers.
So it's not shared. So, for example, some of our partners, we have Boston Children's Hospital. So we curate that data. They only have access to their data set, but
Okay.
we as a team, we have access to everyone's data.
Oh, okay.
So we have like access control, and we use like RBAC and different ways to kind of control who has access to what data. But sometimes, depending on permission, we can grant that access. But there's security, there's management, there's a lot that has to happen behind the scene.
Oh, okay. Are there some a term that I wasn't really that familiar with because like I'm more kind of an infrastructure person
Hmm.
than a kind of a data kind of scientist person, but ETL, extract, transform, and load,
Yes,
right?
sir.
So the way that I kind of think about that is that you're kind of extracting this data, you're putting it into like some canonical format,
Yes.
right? So you're transforming it, and then you're loading it. To me, that means some system is ingesting it,
Yes.
right? So
Yes.
kind of like, all right, good. So I do have a handle,
Yes.
on that. So your group is creating this pipeline,
Yes.
of all that data. So challenges, associated with that, because I would think that the data sets have got to be massive.
Yep.
They've got to be like huge.
Yep.
Like maybe if you can kind of like share what are some of the kind of challenges that you
Yeah.
run into.
Yeah, definitely. Some of the challenges, we call them the three V's. So volume. So we're collecting a lot of data from different departments, different labs, and sometimes they use different ways to store the data. Some labs use electronic lab notebooks. Sometimes it's Oracle. Sometimes it's MySQL. Sometimes it's PostgreSQL. So different sources of data. So when you're extracting that's the E part of the ETL. So you're extracting that.
Yep.
So sometimes you're extracting it at the same time because we need to combine different data from different sources. So, and sometimes that volume can become a lot, especially with like healthcare data, which has been collected for over decades. And you have a set with a million record, and you have to focus on transforming that. The transformation part may sometimes take a lot of time. So, one of the V's, like I mentioned, volume. The second V is variety. So, different types of data. Sometimes it's in a JSON format, sometimes it's in a Excel format. So, it's just very different. So, that you have to take that into account during the transformation. And the last V is velocity.
Um,
So you want the whole process to work fast. You don't want any bottlenecks, especially when we have like real time metrics, especially in the hospital. When a patient goes to the hospital, they're expecting some result. So you want that to be almost real time. So yes, that's some of the challenges: volume, variety, velocity, and just finding ways to build efficient data pipelines, which take all of that into account.
could you give an example, like maybe what's kind of size volume,
Mhm.
that you might be dealing with, like I'm not sure if you measure that on a time basis
Mhm.
or on maybe a project, basis,
Mhm.
I guess like how do you kind of measure the volume?
Volume, just the size of the data in terms of like let's say we have structured data, which is table, columns, and rows. So volume would be, for example, you have 2 million rows. That's a very heavy data set for transformation, especially when you're transforming that using a Python script which handles it row by row. So that can take some time, and you have to do that for 10 different sources at the same time. So that 2 million, if all of them had 10 sources, that multiplies by 10. So that's what we mean in terms of volume.
Yeah, that is massive volume.
Yeah.
That's big volume. And those models then, so once you've kind of like, kind of groomed all that data,
Hmm.
so now it's ready to go into various different AI models.
Yes.
And that's usually the province of the researchers. All
Yes.
right. Okay.
Yes.
And is there a feedback loop, where the reresearchers are saying we need more of this kind of data,
Mhm.
less of that kind of data?
All the time.
Oh
It's
yeah.
all all the time.
Yeah.
It's part of the journey, like
Yeah.
especially being, in the data engineering space, and we always have systems that, break.
Mhm.
So for example, the data quality is also a big part of our data engineering, and especially researchers. They don't just want data; they want data they can trust.
Yeah,
That is
that's
kind of,
huge.
yeah.
Yeah.
So that's kind of like the feedback, the ongoing conversation we always have with researchers on like trying to find different ways to optimize our pipelines. And it's still a work in progress. Sometimes our systems fail. It happens, but we find ways to rebuild it quicker, make it better, make it efficient, and have better results.
Yeah.
So.
Yeah. Awesome. Okay. Um, what is that system? What is all that data being ingested in?
Mhm.
I know that Snowflake is a tool. Datadog is a tool. Are there other data stores, data lakes, out there? But is there kind of a in the cancer research area? Is there like a standard ingestion tool that everyone is using?
Yeah, I've noticed due to research that I've been doing, a lot of people are using Snowflake.
Mhm.
Snowflake, I'm a big fan of Snowflake. I use Snowflake almost every day to that's kind of our main data warehouse. Where we store all our data from the different labs, like I mentioned. So if a lab wants access to their data set, we can just give them access to the Snowflake, and they can just go on Snowflake. And now my team is currently working on implementing LLM, Snowflake Cortex AI, which gives capabilities to build AI with your own data set. So you don't need to get the data out of the data warehouse. You can just build the machine learning and the AI on top of the data set. So we're experimenting with that right now, but it's not yet in prod. But we're very excited.
Yeah, awesome. Yeah, so are there other things that Snowflake offers, both on the researcher side
Mhm.
and also on the data scientist side,
Yes.
that kind of help in whether that's quality control or whether that's just like making things easier,
Mhm.
the flow of data.
Yes, definitely. There's a bunch of tools which Snowflake has. I can't think of any right now, but basically the whole workflow, the whole essence of Snowflake is data storage and having easy access to that data. So that's, some problems which, like I mentioned, volume. When you have a lot of data, it becomes hard to access and query that data, write specific queries. So Snowflake allows that. It has a specific mechanism which makes things a lot easier. For example, if you query the same table 10 times, the time it takes to query that table decreases, because
Makes sense.
Snowflake, yeah, it
Yeah,
keeps that
learns.
memory inside its internal storage.
Yeah.
So I think some of those capabilities definitely help a lot. And just like I mentioned, the ability to build AI on top, like LLM. So we're actually building a tool to help scientists, because some of our researchers, they don't have technical skills like SQL.
Hmm.
So them querying a table is a bit hard. It's a bit challenging. So we created like an LLM where they can basically write a prompt, and it's all connected to the personal data. So they can just write a prompt, and instead of writing SQL statement, they just write a natural language prompt. So
Awesome. Okay, great. Yeah, so great tool, kind of bridging that gap between researchers and
yes,
data scientists.
yes.
Okay, great. So there's a lot of folks at the AI Networking Summit. There's also a lot of folks who are focused on cloud, on networking and security.
Hmm.
So maybe from a networking point of view,
Hmm.
does the network infrastructure ever get in the way, or does that need to be improved in any way in order for like this process, from
Yes.
data, kind of extraction, ingestion, and then resources to access it flow better?
Yes, I definitely I think that network is definitely the backbone of data intensive research. And I believe this conference is the right place to be, to get to learn a little bit more about network, what it means, like network optimization technique. And so, for example, some of the data we work with, you don't want bottlenecks. You don't want, the data to be stuck at some point when people really need access to that data.
Mm.
So having like efficient network system to which can you can monitor, especially with AI co-pilots, which I'll be speaking about tomorrow during my panel. Just different tools, different ways to like optimize and monitor networking systems. There's a tool, Cisco AI, which I've recently started learning, very good for network optimization. So
Awesome. Okay, yeah, that's great. I look forward to the session,
thank you.
as well. So, have you noticed, like, over the course of the last couple of years, I would think probably your data sets have been getting bigger,
Yep.
right? And has the network infrastructure needed to be tweaked a lot more? Its capacity.
Yes.
So, is it like under strain? I guess
Hmm.
is really, I think, the question to
Yes.
cover.
Every day, because we're always moving data from one system to another. We always have pipelines working, and sometimes the data becomes too much for the network to handle.
Yeah.
So that's why we have a team on call every day, just paying attention to that, just monitoring the network and finding different ways to improve it every day. So
Yeah. Have you seen like any kinds of like traffic patterns that have changed and that are a little bit less predictable than maybe they might have been, a couple of years before?
yes, I definitely think it depends on the type of data.
Yeah.
So for example, for the pathology department, they have like a lot of images which they use for some of their research. So the network seems to fail a lot with that department. We're not sure why. I think it might be the size of the image.
Could be. Yeah.
Yeah.
Yeah. Yeah, I think like what we've been seeing like with others like around the community is that especially at the intersection between AI and cloud,
Yeah.
those workloads
Mhm.
are creating these very unpredictable
Yeah.
patterns, different kinds of processing, and also latency requirements, and they're like inverting the expectations that we would normally have of networks,
Mhm.
and so that's going to be, I think, a big question that we're going to be addressing here at this
Mhm.
conference
Yeah.
is, okay, what are the new ways in which we need networks to evolve in order to support kind of this AI era,
Yes, I
that
agree.
we're
I
in.
agree. I also
Yeah.
believe as the data size keep increasing because we're collecting more data now, uh, just in terms of IoT, Internet of Things devices, just in the medical field, like heart pacers and all that. That's data you're constantly collecting in real time.
Yeah.
So having networks that can like adapt and be efficient for that as well, I think that is very important. And I think as the data size keeps growing, we'll be finding new problems.
Yeah.
I think that's part of the journey. So
Yeah.
but we're excited to solve it. That's why we're here.
Awesome. Excellent. Disleve, I think that that's it. That was
That's
probably a
all.
really good note to like, can I end this on? This has really been great.
Thank you. Thank you.
Really great to like to talk with you, learn about your background. I love that you have a mechanical engineering, background, as well. It's like I found those courses to be the hardest.
Yeah.
I'm a double E, but I found like moments and oh, what is it? Moments and pulleys, levers,
Please.
all
Oh
all
yeah.
that stuff I
Yeah.
found.
Torque and all
Yeah,
that.
it,
Velocity.
it's like so weird because like that stuff you can actually see,
Yeah.
and you would
Yeah.
think, okay, you can have mental models of that,
Yeah.
but for some reason, like I guess Newtonian physics, I wasn't,
Force is equal mass times acceleration.
I got that,
You got
so yeah, yeah,
that.
that one was okay, but I don't know. It's like but anyway, so it was really great to meet you and
Thank
great
you.
to chat with you.
Thank you.
Great. Thanks so much. Thanks to Self.